In this video, we're going to take a look at internal bits. And now we're going to take a little detour and just look at what memory we have. We've seen the address picker before, and we've seen X and Y, but there's also C bits. C's are internal memories we'll be talking about in this session, and boy, are there a lot of them. Now, there's a lot of different bits, and if we go to the help file and go to help, and if we go into just the index and we look at memory, we see there are X are what are called bits. They can be on and off. Y, the outputs, and a thing called control relays or internal bits. And by golly, there's 2,000 of them, so that's a lot of things to remember. Later, we're going to learn about timers, counters, which are similar to their hardware parts of so much time or so many counts. There are some system ones that we'll learn as we go along. Later, we're going to learn about memory, where we can hold numbers and values, such as the temperature or how many parts made. But for right now, we're just going to focus on control relays. As we look at this application, we can see if we operate X1, the output turns on and stays on, and if we push X2, it turns off. So we've solved this problem in a single rung. However, problems start getting more complex, and having both the turn on and turn off logic in the single rung sometimes become impossible. So we're going to take a look at another way to do this using internal coils. So I'm going to load up a program. And now we see a couple things that have happened. We now have a rung that is this rung. I'm going to add a comment. This rung extends the cylinder, which is a true statement. And this rung retracts the cylinder. And we'll look at it why that is. We see now we'll download this to our PLC. Changing it, taking out a run. So now, you see we're not able to start the system because if we look, Y1 is blocked by C1 being off. The problem is, it looks like we're telling it to retract. Well, when we look closer at this instruction, it says normally closed but on is released. Off is when they push it, so we need to change this to a normally closed on both these. So now we'll put that in. So now we see we're able to operate it, and when the user pushes it, it turns off. So there we've turned it on, it's extended, and now we push X2, which makes rung 2 go active and retract. So this connection is pretty common that we have the opposite here, always thinking kind of in the positive way of, we need a signal. So C bits can be really helpful for being able to do things in steps. It's true we could have used Y2, Y3, but those were created to actually run part of the machine and not keep track of things. And output modules are a certain cost, and wiring them to do nothing makes no sense, so the purpose of C coils. So they're really just like Y1 is sealing in that, hey, somebody has hit X1. We can use C1, C2, etc. for whatever that is. So internal coils, just I use for logic. And remember, we can use them over here. So that could be a C, this could be a C, whatever we want. Later, we're going to use C bits with an HMI, which is a touch screen that people will use. So that's the purpose of using control bits. And this ends this video. Thank you for watching.